Hi, welcome to another session of the Potter's Roundtable from Washington Street Studios in snowbound Bolivar, West Virginia. I'm Phil Bernberg, and today's topic is Ash Glazes.
Welcome to the Potter's Roundtable, a monthly podcast where we share our passion for the ceramic arts and a collection of topics specific to potters. Remember to subscribe so you don't miss a single episode. Enjoy the show.
Okay, ash glazes. Well, first of all, what is an ash glaze? Well, first of all, it means that ash from burning something, generally wood ash, is an actual ingredient in the glaze. And also, when most people think of an ash glaze, we think of a glaze that's a runny glaze that forms what are called rivulets or strings and flows down the pot, as you can see in this particular illustration. That's a good example of the way an ash glaze typically behaves, flowing down the pot in these sort of streams or rivulets. The first ash glazes were probably accidental, with ash landing on pots, wood-fired pots in ancient kilns. And then when you got to high enough temperature, typically around 2100 degrees or at least above cone 3, the ash would start to actually melt and react with the raw clay, because in those times they weren't doing bisking, so it was raw clay and ash landing on it. And the ash would actually react with the clay and form a glaze. And they believe, from what we found archaeologically, that this probably first occurred in China. And so that was just basically sort of the accidental formation of ash glazes. Later on then, potters learned to actually adapt this and take the wood ash from the fire, from the pit, and mix it with the same body clay, and then apply it to the pots. So this was actually the beginning of making a glaze using ash as an ingredient. And they have found actual examples of this in China dating back to the Shang Dynasty, which is like the early Bronze Age. So we're talking 1500 to 1000 BCE, the Chinese were making ash glazes intentionally to put on their pots. And then after that, basically the composition of glazes using ash continued to evolve with the modifications and additions of other ingredients. Probably one of the next ones, or one of the first ones to be added, was limestone was added to the glaze, which would be a source of calcium. And then also what was used were feldspar containing rocks, like sodium feldspar and potash feldspar. Feldspars were added, and finally colorants were added to the glazes. Let's talk a little bit about ash. There are different kinds of ash, or if you want to think of it as the residues from burning, and there are three general categories. There's wood ash, and there's grass ash, things that are in the grass family, and then there's coal ash. And so one of the differences, or if you look at some of the differences, is that wood ash is very high in fluxes. These are sodium oxides. So this is sodium oxide. So a lot of sodium, a lot of potassium, a lot of magnesium, and especially a lot of calcium, and some silicon, but not a whole lot, but very heavy on the fluxes. Grass, anything in the sort of like wheat straw or rice straw, or even just grass that grows in your lawn, really has a lot of silica in it, but not much, a little bit of potassium, but not nearly as many fluxes as in the wood ash. And the coal ash is really heavily in aluminum and silica, because actually there's usually a lot of clay contamination in the coal ash. So, and again, not many fluxes, mostly alumina and silica. So what we're going to be talking about here today, we're going to talk a little bit, or mostly about wood ash, and we'll touch a little bit on grass and coal ash a little bit later on. So wood ash is, because of these differences, wood ash is used primarily as a source of fluxes. The grass ash, when it's used in recipes, is used primarily as a source of silica rather than fluxes. And the coal ash really is not very common. I was able to find a recipe or two for using coal ash, because if it's available, you might want to try to include it in the glaze, but the use is not very common, because it's not really providing any fluxes, and the alumina and silica you can get just as easily from clay. So let's talk about wood ash, first of all, since that's the most common kind of ash we're going to be dealing with. First of all, there's a lot of variation among ashes from different kinds of wood. And so I think this is just an example of two different sort of general categories: hardwood, represented by oak, and softer wood, represented by pine. And there's a difference in the types of elements they're getting from the ash, if you notice. Like in the hardwood oak ash, for instance, there's not as much potassium as there is in the softwood, but there's more magnesium. And there's more silicon than there is in the softwood, and there's more of the phosphorus. So there are differences in the ash content, mostly in the flux content is what we really care about. There are differences in the flux content between hardwood ash and softwood ash. The other thing I wanted to mention also is that if you're burning wood intentionally to produce ash, and this is done by a lot of potters that have a preference for a particular kind of ash, the ash content of most wood is actually very low, typically around 1/2 of a weight percent. 1/2 of a weight percent of the weight of wood, dry wood, is all you're getting ash. So you have to burn a lot of wood if you're planning to burn ash to burn wood to generate your own ash. And the hardwoods generally have a slightly higher percentage of ash than softwoods. The other thing to point out here is that there's also a lot of variation among the ash that you get from different parts of a tree. So this is just one example that I took from this book by Robert Tishane, that just as an example of, they did some chemical analysis of the ash that was generated just from the bark and just from the trunk and just from the branches. And you can see there are considerable differences. For instance, calcium, there's a lot higher calcium oxide in the bark than there is in the trunk and the branches, whereas the trunk has a lot higher potassium. So what this is all leading to is that there's a lot of variation among the ashes and the ash supply. And then in addition to these changes that we talked about, there are also environmental effects on the ash. So the same kind of tree located in two different locations with respect to sun, soil composition, water supply could have totally different values for all these percentages in addition. So, and especially, for instance, the soil composition. These are minerals that are taken up by the tree. So the soil composition can have a big influence on it. So the point I'm making here is there is no standard sort of number or percentage for anything, for any particular ash. So I guess the main point I'd like to make is don't put too much confidence in specific numbers. If you see a recipe for a certain type of ash quoted in a book, I would almost say don't believe it, because it depends on so many different factors. So what I really recommend is if you're going to get into making your own ash glazes, test with your own ash. You don't necessarily have to have a chemical analysis done, but do all the testing with your ash. You can get some general guidance from some of this information to say, okay, we know, for instance, that the bark is a good source of calcium in general from hardwood trees. So that's it. But other than that, I wouldn't rely on a particular percentage. So it really points to the fact that you need to test with your own ash. Okay, and there are three sort of general categories of ash glazes, or 3 different kinds of ash glazes that we're going to talk about. The first one basically are just the typical, what we sort of think about as the typical runny ash glazes with the flow patterns on them, the rivulet patterns that we showed in the first slide there. And they have a low viscosity, which means that they're runny. They tend to flow a lot. But they have a high surface tension, which means that the melted glaze wants to pull itself together, which is why it tends to form these streams or these rivers rather than flowing in sheets down the kiln, down the pot. It tends to break up into these streams. And you can relate this back to the flux composition. The alkalis, sodium and potassium, are the ones that tend to make the glaze very runny. But the calcium is the ingredient that tends to make the glaze with the higher surface tension and pull into rivulets. So when you have both type of fluxes, it creates this condition where you get a very runny glaze, but a glaze that flows down in these rivulet patterns. So that's the first kind. That's the typical ash glaze we think about. The second category is there are ash glazes that contain less amounts of ash in them, and the ash is really just intended to be another source of flux, and the glazes are not particularly runny. So if you looked at the glaze, you might never know that it actually contains ash as an ingredient. It looks like any other glaze. And then finally, the third category are fake ash glazes. These have the same characteristics generally as the first ones. They're runny and they flow and they create these nice patterns, but they actually contain no ash. What they do is they have a combination of ingredients that create the same chemistry, the same combination of elements as the ash would, so they give you the same results, but they actually contain no ash. I have a couple of recipes for those that we'll talk about later on. So they're called faux, or synthetic ash glazes. Okay, Well, there are two ways or two approaches that you can think about for making ash glazes. You can develop your own glazes with your own ash supply and ingredients, and basically start from scratch and develop your own. Take your ash and say, okay, I'm going to use this as a flux source, and then I'm going to develop my own glaze around it. Or basically, you can just there are a lot of ash glaze recipes that have been published, so you can just take your own ash and just substitute it in these published recipes and see how it works. And if necessary, make adjustments to it. By the way, I guess at this point I'll mention there are two books out there that I used and I referred to that have, both of them have ash glaze recipe in it. First one is Ash Glazes by Robert Tushane, and the second one is Ash Glazes. This is the second edition by Phil Rogers. And both of these are good sources for recipes for ash glazes if you just want to try, as well as background information, if you just want to try swapping your own ash into an existing recipe. Okay, well, if you're going to make, whatever you're going to do, if you're going to be developing your own ash glazes, using your own ash, the first thing I would recommend is, let's talk about how you prepare the ash. Well, there are really two ways that you can use, that ash is used, and you'll see this quoted in some recipes: washed or unwashed. Unwashed means basically just the raw ash, and we'll talk about that in a minute. Washed means it actually has been mixed in water to remove some of the soluble flux materials. Some of the sodium and potassium compounds that are in the ash are actually water soluble, and you can remove them with washing. So in some cases, people have wanted to remove those first before they use the ash. The one thing I would recommend when you're working with ash glazes is, especially if you're planning on developing your own, is collect as large a supply as you can at one time and dry blend it. Because of all those factors that I mentioned before that can contribute to the variation of ash, if you burn, let's say you burn wood in a wood stove or a fireplace, there's no guarantee at all that the ash that you burn one time is going to have the same composition as the next time. Because one time might have more bark, another time might have more branches, it might come from different trees. So I really recommend, since you're going to be trying to establish a composition, get the largest supply you can at one time and dry blend it, so at least you have a supply of ash. You don't know what the composition is, but at least it's all uniform, so that it's not going to change as you're doing tests or later on as you're actually making up a glaze batch. So for unwashed ash, the first thing you want to do probably is to screen out the really coarse materials like charcoal, and there might be pieces, if you've been burning scrap wood, there might be metal hardware in there like nails or pieces of hinges or anyway, so you want to screen that out. And I usually recommend using like a 1/4-inch mesh screen, or even just a piece of old window screen works usually pretty well. And then once you've gotten out the really coarse materials, then I'd say work it through a finer screen to get it down to a fine enough size to actually include in the recipe. And I would recommend something in the 60 to 80 mesh range is fine. Make it fine enough. And you don't have to, when you're doing this, there may be some really crusty material in there, almost like what in the other industry would be called almost like a clinker. You don't have to force it all through the sieve. As long as you work it through, but sometimes some of the hard material is actually hard enough where it can actually damage your screen. So don't force it. Work what goes through the screen easily and just throw the rest out. It's not worth worrying about it. One thing I wouldn't mention also at this point is when you're starting to work with wood ash, or especially wood ash, more than other kinds, it's very caustic. So you want to make sure when you're working with it, for instance, I even recommend maybe even wearing eye protection, because if you get it in your eyes, it can actually burn your eyes pretty badly. So in the dry state, at least, it can be very caustic in terms of inhaling it or getting it in your eyes. So you want to be careful with it, even at this point. For washed ash, I recommend do the same pre-screening to remove the coarse chunks of charcoal and maybe any nails or metal hardware. And then what you do is you take the ash and you actually soak it in water. So what I've done it before, I'll take like a plastic garbage can or plastic trash can and just throw it, and then no proportions don't matter. Just throw it in the water and stir it, and then let it sit overnight. And again, be careful, because now what you've basically made is you've made it, the water part of that mixture is actually now lye. And so it's very caustic, and again, it can actually create burns on your hand, especially if you have sensitive skin on your hands, and you definitely don't want to get it in your eye because they actually burn your eyes. It's very caustic. But anyway, so you stir it in the water, let it sit, I'd say, overnight, and then I drain off the water, pour the water off. And by the way, be careful where you pour that water, because that is very caustic. That's lye. So if you don't go out and pour it under your favorite rhododendron tree, because you won't have a rhododendron tree anymore, okay? So, and then I usually recommend repeat the soaking and the pouring off the water at least 2 more times, or if you really want to be thorough, if you do, assuming you don't mind doing it, if you dip your hands in the ash and the water and you feel it, it'll actually feel kind of soapy and slick. The reason why is because the lye in the liquid is actually making soap out of the fat in your hand. And so what you're feeling actually is the human soap that you've just made by putting your hand in the lye. But when you've washed it enough to get rid of all of that, it won't feel soap. The lye won't be strong enough to react with your skin, and it won't feel soapy anymore. So that's kind of the real test, is that if it doesn't feel really slimy and slippery and soapy, then you've gotten most of the lye out of it. And then when you've finished, depending on how patient you are, however many cycles you want to do, when you've finished washing it, then you can just pour the water off. And I usually just drain it. I'll take a screen that I have and maybe put a piece of cloth over it, like a piece of old bed sheet or something like that, to catch it, and then just drain it and let it drain and dry on the screen. One final comment also is the fact that now when you've washed the ash, you've removed a lot of the sodium and the potassium from the ash. So the ash basically is no longer as concentrated in fluxes as it used to be. So you might have to use more washed ash than you would the same amount of unwashed ash, because you basically made it sort of less concentrated. Okay, so how can you develop, actually, what are some procedures for developing your own ash glazes? Well, remember, keep in mind, with wood ash, we're primarily using the wood ash as a source of flux. So if you go back to the old principles of the Seeger formula, if the wood ash is going to give me at least all or part of my fluxes, now I need to add aluminum oxide, alumina, to the stabilizer, and I need to add some silica. So that gives me a clue as to what other ingredients I might need to add. Well, an easy way to start is to just mix ash and clay, because the clay will provide the alumina and silica, and the ash is enough to provide at least a mix of fluxes. So you can start with any clay. And a good way to start, if you really just want to take a shot in the dark, is a 1-to-1 mix of any ash, any wood ash, and any clay, and you will get some kind of an ash glaze. Depending on the type of ash and the type of clay, it might melt at cone 6, it might melt at cone 8 or cone 10, but you will get an ash glaze. But a good way, if you really want to pursue this, is to do a line blend. And a line blend, basically you set up, this is just sort of a diagram of how you can do it, is you can just take, this is my pure ash, and I'm just going to take, make a small addition of clay to it. And then I'll make another addition and another addition and another addition, and I keep adding clay in small amounts and recording the amount I'm adding, and then I can test all of those to see where they melt. And so you can do this in very small amounts. And what I've done sometimes is I'll just take a tile, like a clay tile, and break it up and put each one of these samples in an area on the tile and fire it, cone 6 or cone 10, whatever you're shooting for, and see what composition do you need to actually melt and give you a good-looking glaze at your particular temperature. This is an easy way to start, okay? The next thing you can do, so this is really basic. At this point, all you have is a mixture of ash and clay, and now you might want to refine it and start looking into other ingredients. What else can I add? Well, what I can do then, I can do another line blend. Only in this case, I can take the clay and ash blend from the first test, the one that seemed to work the best, and now add small amounts of a second ingredient, like feldspar. And I can do the same thing. Take the clay and ash mix, add a little bit of feldspar, a little bit more, a little bit more, a little bit more, and do the same thing. Do a fusion test or a melting test on a tile, and I can see what seems to work. And this is a really easy approach. Or, if you want to start from the beginning, instead of doing a line blend, you can do what's called a triaxial blend. Now I've picked, in this particular one, I picked what I thought was the best clay ash composition to start. But I can do a triaxial blend, where I look at all 3 possible combinations at once. So I look at ash, and I look at clay, and I look at, let's say, my other ingredient, which I've decided to make it feldspar. And what this does is I can set up different this is a composition diagram. So this represents 100% ash, and this represents 100% clay, and this represents 100% feldspar. And so what this diagram is just representing is all the possible combinations of composition. Not just shown 10 of them here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this point here represents a certain proportion of ash and clay and feldspar. And I can draw the lines in. But anyway, so like this, and I can make smaller subdivisions. This is just a way of diagramming. So I could, to start, if I wanted to, I could make 10 different trials of plain ash, well, I don't need to do the plain ash and the plain clay, but like for instance, this one right here represents 2/3 ash and 1/3 clay. So I can make up all these, put them on tiles again, and without having to select anything at all up front, I could just test these and see what composition gives me something that looks like a nice ash glaze, okay?
Thanks for watching this video. Please like, subscribe, and share it with your friends. And consider becoming a patron of our channel. Visit www.patreon.com and search for the Potter's Roundtable. Any amount you give will support the creation of a digital library of educational videos and podcasts to support artists, potters, and educators now and into the future. If you would like more information about our membership studio, classes, events, and multimedia productions at Washington Street Studios, visit our website at www.hfclay.com.
Another thing I can try is I can take the best recipe that I get from this, or the first approach, and I can say, okay, now I'm going to try a different kind of clay. That was a clay that I had. I'll take exactly what I had before, and I'll swap a different clay in and see what happens. Or I'll try, instead of feldspar, I'll swap in a different flux. Maybe I'll put in, now let's try the same thing with whiting instead of the feldspar. So I can gradually, I can explore in a lot of different directions to see the effects of what these different ingredients are going to give. And then eventually, if I get something that I like, I can start thinking about adding colorants to it. Or I could add opacifiers to it. If I don't want a clear glaze, I could think about adding, for instance, zircopacks to it, as you'll see in a couple of recipes that we'll talk about later. I can make it a little more opaque. So, to give you another example, if I did the ash, and I just did, let's say I just started with ash and feldspar to start, instead of ash and clay, because there's no reason why I can't do this. Because remember, feldspar also contains a flux plus alumina and silica. So in this case, I'm getting the flux from the ash plus the flux from the feldspar plus the alumina and silica. So theoretically, this could give me a balanced glaze. So if I take this and I do a line blend, and I might find out that ash 60 parts and feldspar 40 gives me what looks like a pretty good mix. And then I can say, now I'm going to do a blend with that. So then I take this and I add clay to it. And I add clay in little amounts, the same approach, until I get a nice mix. And I might find out, finally, that I end up with something that looks like this, like 60 ash and feldspar 40. These are parts. This isn't percent. And clay 10. And that gives me a really nice glaze. And actually, if you do this, this will give you a pale green celadon. This gives you a very nice celadon-like glaze at cone 10. Okay? Okay. Adjusting or altering glazes. So if you make up a glaze and you like, let's say you like the looks of it, but let's say it's a little too runny, it's a little runnier than what you'd like, well then you could, again, just like with any other glaze, increase the alumina or increase the clay, or decrease the fluxes. Since now you have all the ingredients at hand, you could change the recipe either way. You could add more clay, or you could reduce the fluxes to make it less runny. And if the fired glaze looks too dry, too matte, then you could increase the fluxes, or reduce the clay, or also add silica. Because again, if it's not glassy looking enough, it means there isn't enough glass forming. So you could add the two things that would help make more glass: more flux to make it melt, and more silica to make more glass. And finally, if you're just going to be using like a published glaze recipe, and we'll be talking about a number of these in a minute here, basically you could substitute the ash. You could start off with, so you could substitute the ash for a glaze, for a flux in any recipe. not an ash recipe. Any recipe, you could say, I'm going to take this flux, a particular flux, let's say Gerstli borate, and what happens if I take out the Gerstli borate, all or part of it, and I put in my ash? So that would be one way to explore it. And especially since we know that wood ash tends to be high in calcium, I could look at a recipe, any recipe, and if I could see one of the ingredients that supplies calcium, I could say, okay, instead of the whiting in this recipe, which we know would be a source of calcium, I'm going to put in my wood ash. And that would be a perfectly logical approach, and see how the wood ash would substitute in different amounts for the whiting in the glaze recipe. Okay? So, for example, there's a classic recipe for what's called a 4-3-2-1 glaze. This is from Bernard Leach. He popularized this, what he called a 4-3-2-1, because it's the proportions 4, 3, 2, and 1. And 4 was feldspar, and 3 was silica, and 2 is whiting, and 1 is clay. And these materials in this will give you a really nice, again, a celadon-like glaze in the range of like cone 8 to 10. So I could take this recipe and just say, okay, I'm gonna instead of and we know whiting is a source of calcium oxide, but that's also true for the ash. So I could just look at this recipe and say, okay, I'm going to replace all or part of the whiting with my ash and see what I get. Be a perfectly good approach. And the other thing you can do also, of course, that's for any recipe. Now, the other thing you can do is just look at published recipes, ash glaze recipes, that are already established, and just try your ash in that recipe. And because the ashes are so variable, there's no guarantee that it's going to be the best at exactly the percentage that the recipe quotes, but at least it gives you a starting point for experimentation. So let's look at some of these recipes. Let's talk about some of the recipes that have been published for different kinds of glazes, different kind of ash glazes. Okay, so these, and again, some of these they start out, they're pretty simple. So here, and again, I've taken these directly from the literature. Occasionally there are errors or things that I don't like about the recipe that I'll point out as we go along, but I didn't edit them to put them here. So this is just a cone 10 oak ash glaze, really simple. This is kind of like what I talked about before. Instead of being ash and clay to start, they just have oak ash and Custer feldspar, 1-to-1, and a little bit of bentonite. And the reason for the bentonite in this case, as you notice, is there's no clay in the recipe. So by itself, that would be a really unmanageable glaze. It wouldn't stick to the pot, it would dry and flake off. But the bentonite keeps it in suspension in the bucket, and it also helps glue it onto the pot when it dries. And then we have, this is Tom Turner's, or one of Tom Turner's cone 10 ash glaze recipes. Now here, and again, sometimes people will put in these different comments. Now you notice here in this first things, they didn't specify whether it's washed ash or unwashed ash. Some people mention that, some people don't. So we don't know. And you might, and there might be, because we talked about the changes that occur in the composition of the ash, there could get significant different results if it was washed or unwashed. So you have to try it. In this case, he specified screened, but he didn't, again, say whether it was washed or unwashed. But now he's got all three of those common ingredients: wood ash, potash feldspar, and ball clay. And in this case, now he's also added 2 colorants, cobalt. Now here's a good example of what I was talking about editing. That's really bad terminology, cobalt, because we don't know specifically what cobalt compound. It's not cobalt metal, obviously. So is it cobalt carbonate? Is it cobalt sulfate? Is it cobalt oxide? What is it? That makes a big difference. So this should be written a lot more specifically. It should have been cobalt carbonate or cobalt oxide, not just cobalt. Because if this was just plain cobalt oxide, that would be a lot stronger than cobalt carbonate. So it would come out a lot darker blue. Okay, but anyway, so there's, again, a really pretty simple recipe. Okay, here's another one, cone 10 cream ash glaze. Now in this case, they specified washed, soda feldspar, and ball clay, the same 3 ingredients, slightly different proportions than the last recipe, but now they've also included some bentonite with it. Frankly, in this case, I don't know why you need the bentonite, because you've got 20% ball clay, and that's a lot of ball clay. So I would almost, if I was going to try this one, I almost try it without the bentonite. Now they put in Zircopax, if you remember, that's an opacifier. So, and again, 20%, I would almost look at this one and say 20%, I would start off with half of that. 10% of zircon packs, usually in most glazes, is enough to make a completely opaque white. So I'm not sure why you'd want 20. You could try it to see what you get, but I'm not sure that you need that much. Okay? Transparent feldspar ash glaze, wood ash 28.5, custom feldspar 57.2, and whiting, same kind of ingredients again, bentonite. And the thing I think is interesting about this is, I don't know whether, when you start getting into decimal points with wood ashes, I really question whether it matters, because the ash is so variable in composition that would this really matter whether it was 28.5 or 28.9 or 29 or 27? I doubt it. So, you know, anyway, what I'm getting is, I don't think, and 2.9 bentonite, why not just 3 if you're going to put it in? But anyway, the point is, I don't think you have to worry about those little details with ash glazes. Okay. Cone 10 old gold ash glaze, wood ash. So, and here now they've actually got 2 decimal points. We can tell somebody did this on a calculator, okay? Wood ash, soda feldspar. Now they've also included dolomite instead of whiting, which is kind of interesting because they're putting in more magnesium from the dolomite and clay. And now they've added rutile as a colorant, which is really what's probably giving them the gold, what they're calling gold, this yellow coloration to it. Japanese, Cone 10 Japanese Nuka glaze, milky white. This is actually a Nuka glaze. I'm looking through my notes here. A Nuka glaze was a traditional Japanese glaze that used rice hull ash, the ash from burning the hulls on the straw when they harvested the rice, and it was used as a source of silica. So they used in the original traditional Nuka version, they used wood ash. And instead of using Cornwall stone, this is probably an English recipe, they just used feldspar, but then instead of the silica, they used rice hull ash, which was a source of really, really fine white silica. And the main reason why the glaze came out milky white, because of all this fine silica that was in the glaze. So this is sort of a Western adaptation of a Nuka glaze, of what would be a traditional Nuka glaze. And here's a Hagi glaze. This is another Japanese glaze. And again, it's the idea, in this case, they're calling for rice ash. And again, the rice ash is really a source of silica. So you've got wood ash, feldspar, so there's your fluxes, and your aluminous, and the rice ash is giving you more silica. And again, it's opaque white because there's so much silica in it, basically, that it's acting like an opacifier. Chun ash glaze. Now you notice now we're no longer, all the previous glazes we were talking about are Cone 10. The glazes for the next few glazes are going to be going down in temperature, so we can see the slight differences in composition. So this is Cone 9 ash. Now in this case it doesn't say, I assume it's wood ash, but it doesn't say, which would be better if it did. Potash feldspar, bowl clay, and red art is a kind of earthenware clay. And the red art is probably in there for color. It's a source of iron, and it's also a source, and it's an additional clay. So it's a colored clay basically. So it's probably in there mostly for the iron to color as a colorant for the glaze. And here's another one now, Cone 8, wood ash, custom feldspar, and silica. So we've got a lot of fluxes now in here. Wood ash is 46%, custom feldspar is 46%. We're adding a little bit more silica, but you can almost look at this recipe and guess that it's probably going to be a little lower temperature than Cone 10 because there are so many fluxes in it. You notice there's no clay. No clay in it. So this is going to be a bear in terms of applying. It's going to settle out like concrete in your bucket, and it's going to be kind of a bear to apply to the pots because it's got no clay to stick it onto the pot. Okay, now this, I put these two up here to further emphasize this point I wanted to make. Here's Frasca wood ash glaze Cone 6. And here's Ernie ash glaze Cone 10, and basically the recipes are identical. So how can this be a Cone 6 glaze and this be a Cone 10 glaze? Well, the answer is they're probably both more likely, I think, Cone 6 glazes because, again, they have a lot of fluxes. Wood ash, unwashed, has a lot of fluxes in it, plus custom feldspar, plus whiting. This is all, that's like 75% flux. So I think it's more, so at Cone 6, it may be less runny, and at Cone 10, it's more likely to be very, very runny glaze. So again, what I'm pointing out here is don't trust, when you see a published recipe, you can't necessarily trust the cone rating that's given for it, because it might melt adequately to be a glaze even at Cone 5, but if you really wanted a runny glaze for this composition, then you might have to heat it higher. So this is, again, where I say you really need to test with your own ash and decide what's the appearance of the glaze that you want and develop it for that. You can't necessarily just take it straight from the description in the recipe. Okay, and here's now we've gone down to cone 6, so we've got wood ash, Gersley borate, whiting, EPK, and silica. And so one of the giveaways that these are more likely cone 6 is the Gersley borate. Because Gersley borate, we know, is a flux that's used in cone 6 and earthenware recipes even. So when I see this much of a recipe, this much of this kind of a flux, it means I'm trying to force it to melt at a lower temperature. So in the same way over here, I've got wood ash, which is a flux, and whiting, and I've also got lithium carbonate, which is another low temperature flux. So I've got 2 low temperature fluxes. So you can almost guarantee that this is lower temperature at least than cone 10 or cone, that the higher stoneware temperatures. And finally, here's an 04, an earthenware recipe. Wood ash washed, 45%, frit 3134. As you're probably aware, most of the common frits, and by the way, 3134 is the substitute for Gersley borate in frit form. So, and as you're probably aware, most frits that we used for pottery actually melt at earthenware temperatures. So if I put a significant amount of a frit in any other glaze, like a cone 6 or cone 10 glaze, it's going to start, that ingredient is going to start melting a lot lower. So I've got wood ash, which has a lot of fluxes, ferrofrit 3134, which is an earthenware melting material, and Custer feldspar. I've got a huge amount of fluxes in there. So it's very reasonable to just look at this glaze. Remember, in one of the other discussions, we talked about how you can look at a glaze and you can sort of learn a lot just by looking at the recipe. Well, looking at this, knowing that this has a lot of flux and you've got this, you can almost guarantee that this is going to be an earthenware type glaze and not even as high as cone 6. Okay. Now, this I mentioned in the third category when we were talking about ash glazes, is that the third type of category is ash glazes that are synthetic ash. They don't actually contain any true ash. Well, so now if you think about it, that means I can make a combination of ingredients that have the same composition as ash but contain no ash. So that's what these are. These are recipes for actually making up just the ash, not a glaze. So if I combine, so this is limestone dolomite. Pearl ash, by the way, is potassium carbonate. The same way soda ash is sodium carbonate, pearl ash is potassium carbonate. If you want to make some, take your mother's pearl necklace and burn it in the kiln, and you'll end up with a small amount of pearl ash, okay? And then bone ash and iron oxide. And here's and this is from Tishane. Here's another recipe that was duplicating washed ash, because the washed ash would have less sodium and potassium than this would. So potash, feldspar, whiting, talc, bone ash, ball, and clay. So this is just, so if I wanted to go to all this trouble, I could make up one of these recipes and then add the other ingredients to make an ash glaze. Because these are only the recipes for just the ash part. Okay? All right, so let's move on here. Now we're getting into the synthetic or the fake ash glazes. These are these glazes that have the same general characteristic as true ash glazes. And by that I mean especially what people are trying for here is the runny glazes. The runny glazes with the formation of rivulets. If they're not looking for rivulets and this flow pattern, then there's no point in going to all the trouble to make fake ash glazes. So they're after that classic look. So here's cone 9 to 10 fake ash rivulet glaze, ball clay, whiting, strontium, dolomite, silicon, red iron oxide. And so that's going to have, and especially since in the title, they're trying to make this flow pattern like we showed in the first figure. Here's a lower temperature one, cone 5 to 6, and they even tell you up front that it is going to be runny. Red art, again, is this earthenware clay, and there's a lot of it in there. So it's not just for the color then, it must be in there also just the fact that it is a clay, but it's also providing iron as a color. OM4 is ball clay, so there's a lot of clay there. There's 47% clay in this one. But I've got strontium carbonate, I've got dolomite, Gersley borate, bonate, lithium carbonate. So I've got 4 fluxes here: strontium, dolomite, which is magnesium, calcium, Gersley borate, which is boron, and bone ash, which is calcium phosphate, and lithium, actually 5 fluxes. So I've got a lot of fluxes in here. So it's not surprising that it's going to be runny. So I've got aluminum oxide that's coming, for instance. Do I have any aluminum oxide in here? Actually, I've got a little bit coming from the bentonite, but not much. So I've got aluminum oxide and silica coming from the clay. So that's giving me most of my aluminum and silica, and then all these fluxes. So that is going to be a runny glaze. But again, there's no ash in it. There's no wood ash anyway. Okay. There's another fake ash glaze, Cone 10, Cedar Heights Red Art. That's the same red art, and only in this case they specify the supplier as Cedar Heights. Strontium carbonate, whiting, and 3 colorants, red iron oxide, yellow, and bentonite. Now again, why you'd need bentonite with 60% of red art clay, I'm not sure, because the red art clay is certainly going to hold it in suspension. And so I wouldn't even, I don't know why you'd need that. But anyway, some people, force a habit. And Ashley's Cone 6 fake ash rivulet glaze, ball clay, strontium, dolomite. Again, so I've got clay, a lot of clay, some silica, and 4 different kinds of flux, strontium carbonate, dolomite, ferrofrit. Again, 3134, so that's a low temperature frit. So we know that and all the other fluxes, this is going to be either a low temperature and or a runny glaze. Bentonite, iron oxide, and titanium oxide. Titanium is in there as an opacifier. That's going to make it white and tend to make it, so with the combination of the red iron oxide and titanium, it's going to be probably sort of an opaque reddish brown. And lastly, we mentioned that, I touched a little bit on the fact that you can actually, you can get ash from burning coal or coke, and it's not very common to use it, but, and also because it's, a lot of times, unless you happen to live near a coal-fired plant or something, it's hard to have access to, but you can actually make glazes with it. So in this case, here's a recipe for a coal ash recipe using coal ash, 20%, Custer feldspar, whiting, gold art, clay, silica. So in this case, all the coal ash is really mostly adding, if you remember from that earlier slide, it's adding mostly alumina and silica. So I still need the Custer and the whiting and the magnesium. I think the magnesium carbonate is there maybe to make it crawl a little bit. But you still need a lot of fluxes, the feldspar and the whiting. So I'm taking advantage of the fact maybe that I have this readily available coal ash, but it's not giving me, I don't think, anything particularly unusual that I couldn't get with other ingredients. It's not providing really much in the way of fluxes, and I'm adding rutile, and there's a little bit of iron in coal ash, but I'm adding rutile and I'm adding more iron than's present in the coal ash anyway. So I think in this case it might almost be just the novelty of being able to say, well, I made a glaze out of coal ash, but it's not providing anything particularly unique to this recipe. Okay, well I think that's all we had today for this topic. I hope the topic was useful, and thank you very much for joining us today. Well, we hope that this discussion today has been useful. We know that this was a lot of information in a short period of time, so if you'd like to hear it again, you can listen to our podcast version of this presentation. Just search for the Potter's Roundtable on your favorite podcast platform. If you enjoyed the presentation, please like it and subscribe to our channel and share it with your friends and other potters. This really helps our videos get found on YouTube. Also, if you have any suggestions for future presentations, please let us know. We're open to suggestions.
The Potter's Roundtable is brought to you by Washington Street Studios and our patrons. If you enjoy the show, please subscribe, give us a 5-star review, and tell your friends. If you want to learn more about Washington Street Studios and shared studio memberships, please visit our website at www.hfclay.com. Thank you, and we'll see you again next time on the Potter's Roundtable.